Hey everyone, welcome again to my weekly show. Wait, it's not gonna be a weekly thing, I don't know. But anyway, as you can see over here, we have two bots, twice the fun, twice the excitement, and we have a solution for the third part, which might make our assignments complete, and we can submit it 2 weeks before the new extended deadline. So yeah, so just a quick TLDR about how it works right now. So we have two bots, one lead bot, one follower bot, and the lead bot just cares about getting to its target position, and the follower bot it tries to keep a certain distance from the first one, or kind of just mirror the behavior of the first one, but it does not really mirror. It just senses how far it is from the first bot and tries to follow it. Just to give you a quick look at the code. So this is it right here. This is the new calculate action function. And I am using Osan's real nice implementation. Thank you, Osan, a lot for your work. Pretty much it uses two PD controllers. So I use like one PD controller for the angle, use the angle error to compute the action value for the angle, and another PD controller for the target position, or the position error, I must say. And at the end, just like adds the two, and that's the action value. I am kind of surprised, I must say, that this actually works that way. It's which is pretty cool. Thank you, Osan, again. What I did, I just, as it says over here, we need to change the interface. So I just changed the interface by adding an integer argument to the function. And this argument right here allows me to tell which pendulum am I computing the action for. So if you go up here to the while loop where the server keeps on tracking the sensor's data, and then use that data to compute the action value for each pendulum. So as we have two pendulums right here, so the array size is 2, so we have two indexes that gets used, like a 0 and 1. And that gets passed to this function right here. So pretty much if the index is 0, that means we are working with the lead pendulum, and if the index is 1 or more, in case we add more pendulums, then we are working with the follower pendulums. And yeah, that comes into play into computing target position, because for the follower pendulum we want to keep a certain distance from the lead pendulum, right? So we need to keep track of the last position of the lead pendulum. So that's what the global variable lead pend pass is for, and it gets updated every single cycle over here, in case, again, the index is equal to 0. Otherwise, we don't change it. Well, yeah, I mean, the third solution, the solution for the third part has been very easy to implement compared to the first two. The first two, it demanded for us to actually understand what the PD controller is, how do you implement it, and how would you choose the values for KP and KD. So there was some theory that needed to be digested for us to complete the first and second parts. So once the first and second parts are done, pretty much the third part just falls into place organically. It does not need much work besides knowing, okay, what kind of behavior we want for the first pendulum, what kind of behavior do we want from the second pendulum, and how do we accomplish that using these PD controllers. And I must say the implementation of Osan's solution is really nice, because it is very, very, very stable. So there's like 3 cases over here that Osan provides to us, and I just use the third case right here. The second case is faster, I know that, but it is a bit unstable at the end, because once it keeps on moving, it overshoots it overshoots beyond the target position. So the pendulum will move beyond the target position, and it tries to correct itself again. So there's like some swaying at the end. For the third case, there is not much swaying. Actually, it gets really close to the target position. So if you can see over here, so the first pendulum is at 1.99, so it's almost 2, and it keeps on steady increase right here. I notice like even when it overshoots it, it starts correcting itself, and it's really nice. And the second pendulum right here is 1.49, so it's almost 0.5 away from the first pendulum, and it's really close. I decided to use 0.5 just to see like how close can we get the two pendulums together, which tells a little bit about the stability of the system. Yeah, other than that, I mean, the solution is very simple. The key was to understand what the hell is this. That was the main issue that we had to work with. But yeah, other than that, I wish you guys good luck for the exam tonight. May your fingers be steady and your minds clear. And I'll see you guys, I guess, next week if you guys want to come and understand like how this works. If you guys are curious, but I don't think there is much to explain over here. Or you can ask me questions on Slack or Osan. I mean, Osan is the one who came up with the idea. I'm pretty sure he knows more than I in some parts of this project. But yeah, enjoy your Thursday nights.